as we move on, we only have one more page. What to do if x is in the wrong spot. Now, what do I mean by that? I mean, let's say that you have a fraction, and who cares? Let's just say there's a 2 on the bottom. And on the top you have 2 plus x. Well, that's okay. If it's addition, all you need to do is rewrite this as x plus 2 over 2, and then end of story, okay? So x is not, in other words, it's not in like standard form. So what we're going to do now is talk about one that might be a minus. How could you rearrange 4 minus x? Well, I'm hoping you guys know. I'm going to walk you through slowly, and then we'll talk about how you can do it quickly. If you pull out a negative here, you could get negative 4 plus x. If you don't believe me, distribute the negative back in. Then you could rewrite that as x minus 4. Again, if you don't believe me, distribute the negative back in and put it in the wrong form. So what I'm trying to tell you is if it's in the wrong way, pull out a negative. If it is subtraction and it's in the wrong spot, pull out a negative and rewrite it. Let's do this faster. Let's say that you have x squared, or excuse me, let's say that you have 3 minus x squared. Let's fix that really quick. Let's pull out a negative and rewrite that as x squared minus 3. If you don't believe me, distribute your negative back in and prove it. Let's do one more. Let's pretend you had 4 minus x. Pull out a negative, rewrite it as x minus 4. If you don't believe me, distribute your negative back in to prove it. Alright, now let's go to problem 3 and look at the title, Recognizing Opposite Factors. What we're going to do is we're going to rewrite the top. Do you notice how the top is out of order? We really would like to refix this as a negative x squared minus 4. Now, did we change the top at all? Absolutely not. We pulled out a negative. If you don't believe me, distribute it back in and prove it. The bottom is in the correct order, so I'm just going to rewrite it as 7x minus 14. Now that it's in the proper order, I'm going to go to my typical step 1, and I need to factor. I am sincerely hoping that you guys remember the top one does factor, and the bottom one you can pull out a GCF. If you don't remember that the top one factors, that it's the difference of perfect squares, you need to go back to chapter 8 and review difference of perfect squares. This is x plus 2 and x minus 2. If you don't believe me, multiply it all together and prove it. Now that we have factored, step 2, we need to say our excluded values. That's when you take your denominator, the variable part of it, and say it's not allowed to be 0. Add 2, x is not allowed to be 2. That's your excluded value. Now we can move on to step 3, and step 3 is the reducing step. Look how we have x minus 2 on both the top and the bottom. That leaves me with a negative x plus 2 over a positive 7. You could rewrite this, or you could leave it as it is. If you wanted to rewrite it, you could write negative x minus 2 all over 7. What did I do? I simply distributed the negative in. So I'll write this or that. I'm happy with either answer at this point in time in your algebra career. Okay, let's look at the got it. Problem A. Again, we'll have to box this off as we move along. I don't like how the bottom is written, so what I'm going to do is I'm going to rewrite it, fixing the bottom by pulling out a negative. If you don't understand how that works, distribute it back in and figure it out. Okay, that would be, now we can move on to step 2 and factor. It doesn't factor, so I'm done. I'm going to write doesn't factor. Other than us pulling out the negative, it doesn't factor. Step 2 is we need to state the excluded values. Remember, your denominator cannot equal 0. So what we'll do is we'll say 2x minus 5, which is your denominator, is not allowed to be 0. That means 2x can't equal 5 when you add 5 over. Divide by 2, x can't equal 5 over 2. That's an excluded value. Step 3, reduce. Notice the binomials are perfect reflections one of another. Or excuse me, they are each other, not reflections, they are each other. So I reduce, and at the top I get a 1, on the bottom I get a negative 1. When you reduce everything, you get 1s left over. Reduce that one more step further, and 1 over negative 1 is negative 1. Let's talk about part B now. Part B, we don't like what, the top or the bottom? Hopefully you think the bottom. This is part B. We're going to rewrite it, keeping the top the same, making the bottom negative y minus 4, or negative the quantity y minus 4. Distribute it back in if you need to prove it. Now, step 1, we factor the top. I sincerely hope you remember that the top is the difference of perfect squares. If not, you need to go back to chapter 8 and look that over. The bottom is negative the same, negative the quantity y minus 4. Step 2, we got to tell the excluded values, and that would be y minus 4 can't be 0, so therefore y can't be 4. There's your excluded value. And step 3, reduce. The y minus 4's cancel. You're left with y plus 4 over negative 1, and you never ever leave just a negative number on the bottom. Distribute it through, you get negative y minus 4 is your final answer. Part C. I don't like how the top is written, so what I'm going to redo is I'm going to take out a negative and make it 9d minus 3 all over 6d squared plus d minus 1. Now in step 1, when we go to factor, you got to take your time on this one, because on the top it does factor pulling out a 3, GCF. 9 divided by 3, there's 3d minus 1 when you pull out a 3. The bottom does factor. If you're clever, you can try to use the top to help. Please pause the video, factor it yourself, and check it. You should get 3d minus 1 and 2d plus 1. That'll give you what you had originally. Step 2, we need to state the excluded values. Okay, and to do that, you do 3d minus 1 is not allowed to be 0, and 2d plus 1 is not allowed to be 0. Solve here. D is not allowed to be 1 over 3. I did that quickly. Take your time if you need to. Over here, d is not allowed to be negative 1/2. Those are what you call the excluded values. Step 3 is to cancel anything that cancels. Notice the 3d's minus 1 cancel, and left with negative 3 over 2d plus 1. That is your final answer. Nothing gets distributed. It is what it is. Last one is part D. You should notice the top is not written as it should be. So we're going to pull out a negative, and we're going to make it 3z minus 3. The bottom is fine. We'll keep it 2z squared minus 2. Be careful with your 2's and your z's. Don't get them confused. Step 1, you need to factor. The top you can pull out a 3 and get z minus 1. So you have a negative from before with the current 3. The bottom you can pull out a 2 and you get z squared minus 1. Put a star here because this is the first time you can see you can factor it twice. You can factor the bottom again to 2 times z plus 1 and z minus 1. This is why when we studied chapter 8 it was so essential that you knew how to factor. Okay, so I reduced it one more time, and this is the new denominator, because it's the difference of perfect squares. Step 2, you need to be able to state your excluded values. Your excluded values are when z plus 1 is not allowed to be 0, and z minus 1 is not allowed to be 0. Therefore, z cannot equal negative 1 here, and z cannot equal positive 1 here. Those are your excluded values. Step 3 is your reducing step. Notice the z minus 1's cancel, and you're left with negative 3 over 2 times z plus 1. If you have any questions, please go to your book, look at the lesson check, and ask me anything you want when you return to class.